All right, so I think that I need to give you a very quick review on wavelength. Now, this is something that we talked about in the UV Viz section, and it's something that's going to continue to creep up more and more and more every time we talk about a new instrument. So, in the previous videos with the UV Viz module, we talked about wavelength. And we said that wavelength is basically the distance between two peaks of a wave. All right, so we can call these the maxima, or it can be basically the trough from one trough. But normally when it's drawn, it's the height of one hump to the height of the other hump. And this is what we call lambda, and that lambda is basically the wavelength. So in the UV Viz region, we said that we have anywhere between 2 to 400 nanometers as far as wavelength goes for UV light. And then we have 400 to, let's say, 900 or 800 nanometers for the visible light. So what range are we working with infrared? That's the question that we're going to have to answer in the very beginning before we go any further with the machine. Now, the same thing, the same definitions are also going to creep up as far as frequency goes. So just a quick review, frequency is the number of waves per second. And this has a unit called hertz, Hertz, just like the car rental place, hertz. So frequency is going to show up as well. It's the same definition that we used for UV Viz. So if you learned it back in the day, it's the same definition that's used in infrared spectroscopy as well, just like wavelength is. The same definition that we used in UV is the same definition in infrared. All right. When we talk about infrared spectroscopy, in UV, we talk about nanometers, right? That was the unit that we kept giving it. But in the infrared world, what you're going to find out is that we're not going to use nanometers really. We dial the machine into a different unit. And the reason I will tell you later. But very rare do we talk about nanometers when it comes to infrared spectroscopy. Now, that does not mean that we can't assign nanometers to it. Of course we can. The problem is that the numbers become quite large because infrared is a very large region. And because of that, we change the unit from nanometer over into something else. Okay, so what do I mean by all of this? All right, well, here's the thing. There's actually three areas of infrared that are very important. The first one is called near infrared, and we abbreviate that as NIR. The next one is called mid-infrared, and we abbreviate that, you got it, MIR. And then the next one is called FAR, infrared, and sure enough, that abbreviation is FIR. Okay? So what we're doing is that we're looking at the electromagnetic spectrum, and we said that, well, this is UV, and this is visible, and we said below the visible is the infrared region. The infrared region is quite large, okay? And because of that, we have a near infrared, which basically means it's near the visible part of the spectrum. Then we have the mid infrared, which is a little bit further away. And then we have the far infrared, which is way, way out yonder. Okay? So this is basically in relationship to the visible portion of the spectrum. Nanometer wise, 2 to 4 for UV, 4 to 9 for Viz. In the near infrared region, we're looking at picking up after 900. So we're going to round this off to make it easy to 1000. And we're going to go from 1000 nanometers to 2,500 nanometers. Now I want you to think about that for a minute. This is a 1,500 nanometer range. 1,000 to 2,500. That's 1,500 nanometers there. The UV was 200 nanometers. That was it, 2 to 4. The visible was 4 to 9. So that was 500 nanometers. Those are relatively narrow. When you look at near infrared, there's 1,500 nanometers there that it takes in consideration. But you know what? We're not done. Because infrared also includes the mid part. And the mid-infrared picks up at 2,500, and it goes all the way to 50,000 nanometers. Now you can compare the different spectrums of light or wavelengths that we're talking about. UV is very narrow. There's not much there in the UV light spectrum. 2 to 4. Visible is a little bit wider, 500 nanometer span. Near infrared is a 1,500 nanometer span. And mid infrared is a whopping 52,000 span or 48,000 span. Well, for far infrared, we're going to pick up here at 50,000, and this is going to go all the way to 100,000 nanometers. Again, very wide range compared to the others that we're accustomed to. So all in all, near, mid, and far is what we label as the infrared region. And that means that infrared goes from 1,000 to 100,000 nanometers. Huge. But out of these three sections, there's one area that's the most important. And that one area is the mid-IR. That is the most important out of the three. And that's the area that we will talk about most often when we talk about infrared spectroscopy. This near infrared is a little too close to the UV or to the visible portion. The far infrared is a little too far away. So Goldilocks likes it right in the middle, and that's the mid-infrared region for us. This is the region that we talk about infrared spectroscopy, and this is how we will begin to discuss how the infrared will do the job that we use it for in the laboratory environment. Okay? So, a little bit about wavelength, a little bit about frequency, and now we can talk about wavelength and compare apples to apples. And if we look at infrared, we see that this is a very wide range. Because of this, these are very large numbers. And those very large numbers sometimes are a pain to write down and keep track of. So again, in infrared, we are going to change our units. And we'll talk more about that when that time comes. But keep in mind that we will not be referring to nanometers here. We will be referring to a different type of unit that you have not seen yet. So in the next video, we'll continue on with some definitions and maybe with some examples of infrared spectroscopy.